In section 2.2, we're going to look at the mean and the standard deviation of a discrete random variable. So our first set of notes, 2.1, we introduced the discrete random variable, and now we're going to look at some statistical calculations that we can apply to a discrete random variable. Just remember when we talked about the mean of any variable x, it was simply computed by taking the sum of all the values divided by the number of values, and that would give us our mean for that particular variable. Now we can kind of extend that into discrete random variables, and we're going to go ahead and look at example 1, and it probably will help make more sense of this. So we have a population of 8 students whose ages and years are given in table 1. So here's in this first table, we have a population of 8 students, and we have all of their ages for those 8 students. Table 2 gives a relative frequency distribution, and we can express the mean age of these students in terms of the probability distribution of x. So we have 8 total students, and out of these 8 students, 2 of them are 19, 3 of them are 20, 1 is 21, and 2 are 21, and 1 is 27. So 2/8 of the students are 19 years old, so that's a probability of 0.25. 3/8 is 0.375, 2/8, 0.25, and 1/8 is 0.125. So the way that we can calculate this probability is take the number of, or the age, in this case 19, times the probability of that age appearing. So we would get 19 times 0.250. Then we would also do 20 times 0.375, 21 times 0.250, and 27 times 0.125. So we multiply those, and then we would add those values together, and that would give us the mean of this particular discrete probability, or discrete random variable rather. And we're just looking at expressing this mean in terms of probability. So what it would be is the sum of all the x values times the probability that our variable is equal to a given x value. So remember, big X is our discrete random variable, little x is the distinct value. We're not computing that value here, but we're going to see that here in a couple of examples. So that first example shows that we can express the mean of a variable of a finite population in terms of the probability distribution of the corresponding random variable. And the notation you see right here is what we just came up with from our previous example. Example 2, we're actually going to apply that and come up with the actual true mean. So the first thing we want to do is, let me change my pen here, to find, so Prescott National Bank has 6 tellers available to serve customers. The number of tellers busy with customers at 1 p.m. varies from day to day and depends on chance. Hence, it is a random variable, and we're going to call it big X. Past records indicate that the probability distribution of x is shown in the table. Find the mean of the random variable x. So this all happens at 1 o'clock. So on one day, somebody shows up and they notice there are 0 customers at the bank. Another given day, they show up at 1 o'clock and there's 1 customer. Another day, there's 2. Another day, there's 3, and so on. And so these probabilities have been computed for us. So to find the mean of this random variable, we multiply 0 times 0.029, which is 0. Then we multiply 1 times 0.049, 2 times 0.078, and we get 0.156. 3 times 0.155, we get 0.465, 0.848, 1.310, and then we multiply this and we get 1.290. And all we have to do now is add all those values together, and when we add that, we get 4.118. And so what this tells me is that at 1 p.m., the mean number of tellers that are busy with customers is 4.118 tellers. And that's how you can compute that mean of a discrete random variable. So using that information, again, we calculated that mean to be 4.118 tellers. And I just used a random number generator using the values from 0 to 6. And I obtained 100 random numbers from 0 to 6. The average of all of these numbers in this table comes out to be 4.25. That 4.25 is very close to our computed mean of the discrete random variable of 4.118. So you can see that this is a fairly accurate way to come up with the mean without actually observing, in this case, making 100 observations. If we went on and did 1,000 observations, we would also find that this mean probably gets a lot closer to our predicted mean of 4.118. Calculating the standard deviation for a discrete random variable is simply going to be the square root of the sum of all the x values squared times their individual probabilities minus the mean squared. And we will see that here in example 3, and then we'll be done with this set of notes. So this is a fairly short set. So I'm going to first create 2 rows. We'll start off with the first row. The first row is just x squared, so we're taking all the values in this column and we're squaring them. Then in the we're going to create a second column, and that second column will be the x squared values times the respective probabilities. So we're going to take everything that we put in our first created column and multiply it by their respective probabilities. So the first one is still 0. The second one is 0.049. The third one is 0.312. The fourth one will be 1.395. The fifth one, let's see, did I jump? No, I'm right. Okay. 3.392. Thought I jumped ahead. The sixth one will be 25 times 0.262, 6.550. And then the last one is 36 times 0.215, 7.740. And now we'll add those together, and we get 19.438. All right, so we take that value, and we're going to substitute that in to our equation that we see right here. So we will have sigma is equal to the square root of the sum of all my x squared values times the probability that this right here is the 19.438 minus our mean squared. Well, our mean we've computed in the first example, which is 4.118 squared. So we're going to take 19.438 minus the mean squared, and then take the square root of that, and what we end up with is approximately 1.6. So roughly speaking, on average, the number of busy tellers is 1.6 from the mean of 4.118 busy tellers that we computed in example 2. And that's how you do the mean and standard deviation of a discrete random variable.